Bismillahirrahmanirrahim. Assalamu alaikum. I am Fakhr Lodhi and this is our 25th lecture of Formal Methods for Software Engineering. We are discussing algebraic specifications. And in the previous lectures, we have seen examples of algebraic specifications and we have seen how can we write algebraic specifications and what are the different tools and techniques available to us. जो चीज़ हम डिस्कस कर चुके हैं, याद रहे कि we said that algebraic specifications can be used or are primarily used to specify abstract data types. These abstract data types are your, in programming languages or programming paradigms context, they are your classes. So we can specify the behavior of our classes in terms of algebraic specifications. And we have seen examples of those: stack and queue and list and so on and so forth. We have seen simple examples where we can use already defined specifications or developed specifications, using those specifications in other specifications to develop and enrich specifications instead of reinventing the wheel from scratch. So ये भी हम इससे पहले देख चुके हैं. Today we shall start discussing the specification of a relatively speaking large system, a complex system, and we shall see how can we first specify different pieces and then put those pieces together and use those pieces that have been developed earlier in our specifications to develop more complex and bigger specifications or bigger systems. The specification that we are going to develop now is the specification of a filing system. जिस तरीके से किसी भी ऑफिस में अगर आप जाएं तो कोई फाइलिंग जो आपकी जो फाइल्स जो होती हैं उसको मेंटेन करने का कोई सिस्टम हो सकता है. तो यहाँ पर भी what we are going to do is we are going to develop a system for maintaining files and documents inside those files. So this is a filing system or a specification of a filing system that we are going to develop today, or at least start talking about that, and then we will ultimately see how this system will evolve. So let me just first talk about and show you what this filing system is all about. Here is a generic look or generic view of the filing system. We have kind of a hierarchical structure here. We have the file system. Inside the file system, your system is divided into regions. So it could be that, we have this whole system for Pakistan, and then we have divided this into several regions, maybe, southern part of the country and the northern part of the country and the western, eastern, and so on and so forth. So there may be different regions based upon different criteria. So, at this point in time, I'm not going to go into the criteria and all that kind of stuff. That is irrelevant as far as we are concerned. But, we have this filing system. Filing system is divided into regions. So files are maintained according to the regions. For each region, we have multiple files. So file system, multiple regions. For each region, we may have multiple files, and for each file will contain a number of documents or may contain a number of documents. So this is the hierarchy of the system that we are going to develop. File system has regions, which has files, which has documents, and the documents are going to have the text that we are going to maintain inside those documents. So here is a very high level generic view of a filing system. It could be any filing system in any typical office in which we have multiple offices and multiple regions, and you will see that more or less they will be divided into this kind of hierarchy. This filing system is, if you look at the structure of the filing system, like I said, that we will have a multiple regions inside this system, and for each region we will have files, and for each file we will have documents, and inside the document there will be the text that the document contains. So this is what the hierarchy is. So in this filing system, there are a number of things that we need to do. Obviously, like I mentioned earlier, that we have number of regions, or we may have number of regions in the system. So we must have some mechanism to create a region and add that region into the filing system. So this is our first requirement. Obviously, when we create, we should also be able to delete, but the delete part we are not going to look in this specification. We are only going to talk about creating and then updating the system. So creating different objects, creating different entities inside the system, and updating those entities and performing different operations on those entities, that is what we are going to discuss in this specification, and not deleting, although in a proper system that should also be part of our system. Anyway, coming back, so we should be able to add a new region into the system. So once we have added a region into a system, or for any system that is already, any region that is already in the system, we should be able to add files into the system. So we should be able to create a new file, and when we create a new file, and that new file is added into a particular region, and so on and so forth. So given the system and the region, we should be able to create a new file and add that new file into that region. After we have the file, we would need to create the document. So one of the requirement for this system would be to create a document and add that document to a file. So given the region and the file, we should be able to add a new document to that file. So these are the basic requirements. Now there are some other fundamental requirements. Given the system, I would want to list all the regions that are there in the system. So that is also one of the requirements that I need to have, and I will need to specify my abstract data type that will handle this particular requirement. So if we should be able to list down the regions in a system, then we should also be able to list down the files in a region also. And we should be able to list down the documents inside the file. So once again, we have these kind of very similar requirements, but these requirements are there for which we need to develop the specifications. And finally, we should be able to search for certain keywords and search a document given some keyword or something, some pattern that we can use to find some entity in the document. So what we are going to do is we are going to structure the system like that each document is going to have a header which will contain some keywords, some information that is a searchable part, and then we should be able to use the keys to search for some document that contains that key, and that should give us a list of all those documents that contains that key. So that is another requirement. So we need to have this kind of a system for which we need to specify using algebraic specifications. अब आप इस सिस्टम को ज़रा देखिए, गौर कीजिए, तो वैसे तो इतना बहुत लंबा चौड़ा सिस्टम नहीं है, but still, relatively speaking, it is a complex system, and the specification would require systematically developing and evolving and building the specification, building small pieces and putting all those pieces together to build that specification. So, जो हमने structure जिस तरीके से बात की थी, let us first try to understand what kind of structure would be needed in that file system, and then what kind of specifications do we need to develop. So let us first look at the structure. Once again, there is this hierarchy. There is this system which contains a number of regions. A region has been divided into three parts: region ID, region header, and a link to the files that this region contains. This region header would have some information about the region, for example, the name and maybe a brief description and so on and so forth. So whatever, we are not going to go into what this actually has and not going to look at the data structure here, but this defines the region. This is what we have. And this region ID is going to be a unique ID of the region that identifies that particular region. So system has a number of regions. What we need to do is we need to be able to add a region to the system, and when we add a region, it will create a structure like this, and then it will give a region ID back. That region ID could be used elsewhere in the system. We should be able to list the regions, and when we list the region, it will produce this region info, which will be a list of region IDs and region headers. So all the region IDs and region headers, they would be listed just like this structure. Then we have a link, maybe sort of a pointer or whatever, I don't know. So we are not going to go and talk about the exact internal representation of this link, but somehow we maintain a link for that region, for the files that are maintained inside this region. So once again, the file has been divided into three parts: the file ID, the file header, and the link to the documents that this file contains. So file ID, once again, is a unique ID that identifies the file. File header is something that describes the file, maybe the name and maybe some other description. We again have the same kind of operations. That is, we may add a file to the region, and then it will create a new file, create a new file ID, and it will give us that new file ID. We may want to list all the files in that region, and it will give us a list of all the files with their file ID and the file header. So the file info will contain that. And then a similar structure is used to store the documents. Once again, for each document, we have these three sections: the document ID, the document header. The document header may contain the name of the document, the keywords, other information about that document, and a link to the text that this document has. Once again, the same kind of operations. We have the add doc, which will create a new doc and put it into a file and return a unique ID. We should be able to list documents, which will give us a list of all the documents with their document IDs and the document header. So here we have this system. स्ट्रक्चर आप ये देखें कि सारे की सारी इंफॉर्मेशन का स्ट्रक्चर जो है बड़ी हद तक हमने यूनिफॉर्म रखा है, और अगर आप इस पे गौर करें तो इट मेक्स अ लॉट ऑफ सेंस. दैट इज, फॉर ईच रीजन we maintain three pieces of information: region ID, region header, and a link to the files that this region contains. The file once again has three sections: file ID, file header, and the link to the documents. And the document has the three sections: document ID, document header, and once again the link to the text that this document contains. Now, there are a couple of things that we need to understand and keep in mind here. We are talking about abstract data types here. I am not defining exactly what is the structure of a region header. I'm not defining exactly what is the structure of a file header. I'm not defining what is the structure of a document header. As far as I am concerned, or the system is concerned, these three could be totally different structures. Same is the case for region ID, file ID, doc ID. Although in this particular case, probably they would be more similar than they would be different. But still, I am not imposing any specific structure onto these things. All I'm saying is, a region has three components, a file has three components, and a document has three components. What are the types of those components? It is, up to the implementation. We are only talking from an abstract point of view. So it is just an abstract specification of the filing system. So ये चीज जहन में रहे कि ये एग्जैक्टली एक ही स्ट्रक्चर नहीं है तीनों जगह पे, और हर जगह पे एक डिफरेंट डेटा स्ट्रक्चर इस्तेमाल हो सकता है इसमें. सेम इज द केस जब मैं उसको आगे बढ़ाता हूं बात को. द लिंक, व्हाट सॉर्ट ऑफ लिंक आर वी मेंटेनिंग हियर? Is it a pointer? Is it an array? Or some other data structure that I have? I really don't care. It could be a relational table in which I am maintaining this information, and I am using maybe a foreign key somewhere to maintain the link between these different pieces of information. But here, I'm not going to specify exactly what that implementation is. I'm only going to talk from an abstract point of view. So ये abstraction इसमें important है to remember. So although the structures, they are similar, they look similar, but it is quite possible they are totally different from an implementation point of view. ठीक है जी? तो ये एक important point है जो आप ज़हन में रखिएगा क्योंकि हम इसको आगे चल के इस्तेमाल करेंगे. Another important thing to note here is, I am not saying that the regions maintained inside the system, they are maintained as a list. No, I'm not saying that. Similarly, I'm not saying that the files maintained in a region, they are maintained as a list. The documents maintained in a file, they are maintained as a list. It could be anything. So once again, there is no specific information about the implementation here. However, when I say generate a list of regions, here I am talking about probably an ordered list. Generate a list of documents, generate a list of files. So this is probably a list, but once again, at this point in time, it could be anything. But, I may go inside and give some more detail about those things. Now, the next thing is, we have this system in which we have to develop the specifications for this complete system, and the operations are create a region, maintain a region, add a file to the region, add a document to a file, list the regions, list the files, list the documents inside the file, then search for a document in the system, and so on and so forth. So I need to write specifications for this system. So if I treat this system as one big system, it is going to be difficult to write specifications for that system. So I will take the approach that we usually take to develop complex systems. That is, we divide the problem into smaller sub-problems, solve those smaller problems, and then put those solutions together to solve that bigger problem that we started with. So in this particular case also, what we are going to do is, we are going to solve this problem by dividing it into smaller problems and then, somehow combining all those things to specify what we want, what we need from this system. So इस सिलसिले में, we need to develop a set of specifications. What are those specifications and what is meant by, those different pieces in the specification? I will talk about that later, but let us, look at the structure of that specification for a little while. So here is the structure of the file system specification. Here is my file system that I want to develop. So there are a number of pieces that I will write specifications for. I have my Boolean. Boolean is going to be used in specification for list, specification for a pair, specification for a quad, and the file system. So we have links from Boolean to all those different pieces. Boolean is used indirectly into this another piece, by map. But we are not going to use it directly. It is going to be used indirectly, because BIMAP uses this list and this pair. Both this list and this pair, they are used inside this BIMAP. And the file system uses list, BIMAP, pair, of course this Boolean, and this quad. So what I will do is, I will develop the specification for this Boolean. We have already seen this specification, but there are slight modifications in the notation that I will show you. We will use this Boolean in the specification of list, pair, and quad. With the help of list and pair, we will specify the BIMAP, and then we will put all these things together to specify the file system. So once again, this is a very simple kind of hierarchy. You read it from top to bottom. The link from an object that is at the higher level of hierarchy means that that specification is going to be used inside the specification that is coming at the level which is under that level. So this is how we read this particular hierarchy. So like I said, that we shall develop these specifications. The first specification that we shall see is the specification for Boolean. In the last lecture, we had discussed Boolean and its specification. So the specification that we are going to use here is going to be almost exactly the same. The only difference will be the notation. So in the previous specification, we used the notation as the prefix notation. So all the functions, that is and, or, and so on and so forth, they use the prefix notation. But a more natural notation is the infix notation. So instead of writing and A, B, we should be able to write A and B, which we use normally. So this is the only difference in this specification. The rest, the axioms and everything is going to be the same. So I'm not going to show you the axioms for Boolean. I'm only going to talk about the notation, and this is the notation that we shall be using later on in developing our other specifications. So let us just have a look at that notation. So here is the sort for Boolean. Once again, it's the same thing that we had last time. We had the sort Boolean, and there are two constants, that is true and false. But here we have a slightly different notation. Not obviously will need a prefix notation. So since it is only one parameter that it takes. But in the case of and, we have this hyphen and hyphen. This hyphen stands for a parameter. So here we are saying that we will have one parameter here and the other parameter here, and the type of these parameters will be Boolean. So we will have a Boolean here. This is the first parameter, type of the first parameter, type of the second parameter. Second parameter will come here. The first parameter will come here. The same is the case for or. We have hyphen or hyphen, and once again there are two parameters, and this is type of the first parameter, this is the type of the second parameter, and of course we have these as the return values. The same is the case with implication and the equality. So the only difference here is that we have a different notation. And this notation is, now we are using infix. Previously, we were using prefix. The rest is the same. It is only how we write it. That is the only difference. Okay. So let us now look at the specification for list. Once again, list, the specification for list is going to be almost the same as what we saw earlier on, but there are slight differences, first in the notation, and then there are a couple of additional things that we have in the case of this list. So we have this list here, and the specification for the list is parameterized. We have seen this parameterization earlier on also, but here it is slightly different and it contains more information. We say that list takes an element as an parameter, and the element has certain properties. That is, whatever element that we use in this list should have these two things defined. The first is the equality. We have this equality which takes two arguments. We have hyphen, equal, equal, hyphen. So this first hyphen is the first parameter, the second hyphen stands for the second parameter. So we say that, for the element that we are using inside this list, this operation has to be defined. So since we are using this sort element, which is supposed to be defined earlier on, this sort ought to have this equality defined in it, which takes two elements as its parameters and it returns a boolean. The second thing that needs to be defined for this element is that we have a special element undef. So if it is not defined, we should be able to have some symbol to represent an undefined element. Then we have the sort list, which uses boolean, and it has two constants: 0, which gives us a list, and undef, which also gives us a list. So 0 generates an empty list. So it is a generator function. So when we say, a list is equal to 0, that basically means that, we have got an empty list. In that particular case, an empty list has been generated. Then we have the list functions, and the list functions are first, which is the same as the head function that we saw earlier on. Rest, which is the same function as the tail that we saw earlier on. Is undef, which takes a list as a parameter and it returns a boolean, and it is going to be true if the list is not defined. Hyphen, dot, hyphen. So we have an operator dot which takes two parameters. The first parameter is of type element, which comes on the left hand side of the dot, and the second parameter, which comes on the right hand side of the dot, is the list, which generates a new list after adding this element to the front of the list. So this is our add method in the new list specification that we saw. Then we have, once again, a member of function which takes two parameters. On the left of it, the first parameter is an element. Right parameter, the second parameter, is the list, and it returns true if this element is a member of the list, is present in this list. So this is the kind of search function that we saw earlier. Then we have this equality. Once again, taking two parameters, two lists, and comparing the two lists and returning true if the two lists are equal. And the last method that we have, that method is at end, which tells us whether the list is empty or not. तो यहाँ पर ये list जो है, once again, a couple of changes here. First of all, we are using the infix notation for the methods that need to be defined as infix methods. और दूसरी चीज जो है, there are a couple of new methods that we are using, and one of them is this constant 0, which creates an empty list. Now, note one thing here, that the list created by this 0 or generated by this 0, the empty list, is not the same as undef. Undef would be, from a programming perspective, for example, if you are writing your program in C++, let's assume. So if you declare a variable, for example, a pointer variable. So when you declare this variable as a pointer, the value that this variable has is not defined. It is garbage. But when you say that this pointer is equal to null, then it contains a value which is null, which is, if this pointer is pointing to a list, then that list would be empty. But the previous case, when it did not have any value assigned to it, in that particular case, we would say that we have garbage there. So there is this slight difference between this 0 and undef. But this difference is, although it seems a minor difference, but from a specification point of view, it is a huge difference, because in the first case, that is when we have the 0, it is defined, it has a definite value, and in the case of undef, it is not defined, and using this thing would most probably cause an error. The rest is the same, nothing very special about it. We have already seen this specification. But, since we have this couple of new concepts, especially the 0 and all those, let us just go back to the slide and look at the axioms written for this list. So I will show you the complete set of axioms that we need to write for this specification. So here is the set of axioms. So first of 0 is undef, and the rest of 0 is also undef. Note here the difference between the specification that we gave earlier, specification of list that we gave last time. In that particular case, we said, when we take the rest of an empty list, we get an empty list back. When we take the tail of an empty list, rest is the same as tail of that previous specification that we saw. So we said that when we took the tail of an empty list, we would get an empty list back. In this specification, we are saying if we try to take the tail of an empty list, what we get back is undefined. So there is a slight change in the specification in this particular case. Then we have the first of undef is equal to undef. The rest of undef is equal to undef. First of A dot B is equal to A, and rest of A dot B is equal to B. Once again, the first and rest is the head and the tail methods. The dot is, it adds this element at the head of the list, in the front of the list. So when you take the head of this new list that has been created after adding this new element, you get this new element back. And when you take the list, the rest of the list after adding this new element to this list, you get the previous list back. So this is what this specification is saying. That is, first of A dot B is equal to A, and rest of A dot B is equal to B. Then we have at end 0 is equal to true, at end undef is equal to false, at end a dot b is equal to false. This at end, once again, in this specification, there is a slight, difference from the previous one, but a very important one. In this particular case, we are saying that if we had an empty list and if we ask this question, are we at the end of the list or do we have an empty list? The answer is yes. And the answer is no in all other cases, including when the list is not defined. So when the list is not defined and we say, are we at the end? The answer is no. So this is, we are not saying that we are giving an answer undef. Now this is a Boolean operation. We have to say yes or no. We could have said, at end of undef is equal to true, but we have chosen not to say so. So the specification is up to us, and it makes some sense. That is, you are at the end only when the list is empty. In all other cases, you are not at the end. Okay, so this is an important point that you need to remember and note. Then we have the dot operator and the equality. We say a dot b is equal to c dot d is true when a is equal to c and b is equal to d. 0 is equal to 0 is true. A dot b is equal to 0 is false. A is equal to b is equal to b is equal to a. The previous operations, they are all, very trivial, so I don't need to talk about those. But, once again, the last one, that is, we are saying a is equal to b is the same as b equal to a. We are saying that this equality is, the order does not matter. So it is, remember, in the case of implication, a implies b is not the same as b implies a. But, in most other cases, it is true. But, here we are explicitly saying that, we have this property, and this property is observed here. Then we have e member of undef is equal to false. E member of 0 is equal to false, obviously. E member of a dot b is equal to e equal to a, or e member of b. This membership function, we have seen already. This is exactly the same definition that we gave earlier on. That is, we said that if we have an element E and we want to check whether this element E was present in this list which was modified after adding A to this list B. So we have E member of A dot B. A dot B means, take this list B, add A to the front of this list, and, give me a new list. So I have this A dot B. I want to check whether the element E was member of A dot B. The answer is very simple. We first compare E with A. And if the two are equal, we say, yes, E is a member of this new list. Obviously, because A is equal to E. Now, what we are saying here is that, if they are not equal, then E is going to be member of this new list if and only if E was the member of the previous list. Now, what does that mean? This is a very important and significant point. It is saying a number of things here, although we discussed it in the previous lecture also, but I would want to emphasize on it again because this is a very important point. And from an algebraic specification point of view, this kind of information sometimes there is this implicit information, but that makes the specification complete. So when we are saying that, this E is going to be a member of the new list, if and only if E was not, if and only if E was a member of the old list. If the element that we added to the list is not the element that we are searching for. So what does that mean? हम ये कह रहे हैं कि ई को पुरानी लिस्ट में जाके सर्च करो और देख लो, और वहां पर अगर वो है तो वो इसका मतलब है कि ये नई लिस्ट का मेंबर है. बट implicitly what it is saying is that except for adding this new element A to this list B, it is not changing anything inside B. If there was an element E which was a member of B before this addition, then this E would still be a member of that list. It is not deleted. And since we are saying if and only if, what does that mean? It means that we are not adding any additional element. We are only adding A to it. So we may be maintaining the old elements, but we could also be adding a few more. But this particular case is saying, no, we are not adding anything in this list. So इस वजह से ये स्पेसिफिकेशन ये कंप्लीट हो जाती है. ये बहुत इंपॉर्टेंट पॉइंट है समझने का और गौर करने का. Although we do not say it explicitly, but it implies कि इसमें कोई और एलिमेंट ना ऐड हो रहा है और ना डिलीट हो रहा है. And without saying this thing, without explicitly saying this thing, we are, giving this information. So what happens here? We have specified Boolean. We have specified a list. Most of it has been the old stuff that we have seen earlier. The list uses this Boolean. Now the first function that we need to specify for our file system that we have not seen is a pair. So what is a pair? Let us look at this pair here. A pair takes two arguments. So this specification is parameterized. We have A and B. The type of A and B is not defined. Once again, it is generic type. But what we are saying is that this equality operation is defined for this A as well as for B, and we have undef defined for A as well as for B. So all we are requiring is that these A and B could be anything as long as these two operations they are defined. We have equality defined and we have undef defined for these things. As long as this is true, we can make a pair of these things. So we have the usual stuff, the pair, the undef, pair, and it uses a Boolean. And we have these four functions, the first, second, pair, and this equality. So it takes the pair as an argument and it returns the first one back. So something of type A. Second returns the B back. I can take A and B and I can create a pair of these, and I can compare these two pairs. So here we are talking about, once again, a generic specification. We can take two elements, and these two elements could be of any types, as far as we have a couple of things defined for them, and we take them and we group them together and we make a pair out of these. And we define these four functions for those pairs. That is the first, which gives us the first part of the pair, second, which gives us the second part of the pair, which takes two arguments and it makes a pair, and equal, which compares two pairs and tells us if they are equal or not. We don't have time to write down the axioms for this specification, although this is a very, very simple specification, and by now you should be able to write this specification on your own. Although we are going to write down the axioms for this specification in the next lecture, but I would encourage you to try to write the axioms for this specification pair on your own and see if you can do that. It's a very simple specification, and we have seen something similar already, which was quad. Quad was, with a different context, but more or less we will have something very, very similar in this particular case also. All you have to do is you have to be aware of this undef. So what do you do with this undef? And when one of the things or both of these, they are undef, what do? You have to specify that also. Rest of the specification is going to be very, very simple. Anyway, please do that, and we shall discuss that in the next lecture, inshallah. In the next lecture, we will continue from here and develop this specification for the entire file system. Until that time, Khuda Hafiz or Assalamu Alaikum.